This evening I'm going to be taking apart this electric motor right here and seeing if I can find out what went wrong inside of it. A couple months ago this was installed on my air compressor, and the motor didn't have sufficient starting torque to be able to start the compressor. And I did a video on troubleshooting that, and I was able to narrow it down to a bad inertia switch inside the motor. I'll go ahead and post a link to that video in an annotation below. I went ahead and bought a new motor for the air compressor just because I needed it. Didn't have time to troubleshoot this motor right here. And it's been working fine ever since. But tonight we're going to go ahead and take this motor apart and see if we can't figure out what happened to the inertia switch and get some new parts ordered. Now I don't want to pull the whole rotor out, so I'm going to go ahead and use the C-clamp and clamp it down on the output shaft of the motor here. So when I go ahead and try and take the end cap off, it's not going to pull the whole rotor out. Alright, what we've got here is we've actually got our stationary switch, the contacts right here. And I can already see the problem. I don't even need to really investigate any further. See, this one right here has still got the actual contact on the end of it. This one's burned completely off. It's not even there anymore. So I'm going to see if I can find that piece down in the motor. I probably won't. It's probably either ground up or gone now, but we need to go ahead and get a new one of these right here. Basically what happens is these weights right here that I'm pointing to, as the motor speeds up, these actually pivot up. They pivot up, and all of those together pull on this spring, and they pull this whole assembly back, just like that. And as that assembly goes back, it allows these contacts to open up, which disengages the starting capacitor. So at rest, like it is right now, this thing's out, pushes in on these contacts, which puts the starting capacitor inside the circuit. Once the motor comes up to speed, it releases these contacts, then open up and remove the starting capacitor from the circuit. But with this thing burned off right here, the starting capacitor will never be in the circuit regardless of the position of this. So this is what we need to replace. I'll go ahead and clean this motor up and do some digging online and see if I can find some parts. Alright, I had to do some digging and I couldn't find an exact match for this motor that I got here, but just based on the dimensions, I believe I have located and ordered the correct switch here. Doesn't look exactly the same, but the dimensions look proper. It's normally open contacts. Instead of a jumper wire on this end, it's actually got a permanently installed plate there. But it looks like it's going to work fine. Alright, and using my digital voltmeter, I ought to be able to test this and see if the starting capacitor is in the circuit now. If it is, we'll go ahead and temporarily wire this thing up, clamp it down to the bench, and fire it up. This good little wiring diagram right here that tells me where to take my test points. Okay, I'm going to check between 11 and T5. T4, T8, T1, 7, alright, so T5, and 11 is hooked up to this capacitor. Yeah, so this capacitor is in the circuit now, my starting capacitor. So we'll go ahead and wire this thing up temporarily and see if it starts. I've got this 220 volt plug right here, and I'm just going to go ahead and temporarily wire that up to this, and we'll go ahead and plug it in and see if the motor fires up. Alright, let's see what we get. Alright, well that one was a success. Motor's working properly, and now I've got a spare motor for my air compressor. Time to check that one off the to-do list and move on to something else. Thanks for watching.